We often think of camouflage as a simple act of hiding, of blending into the background to avoid being seen. But for the octopus, this is a profound understatement. It doesn't merely hide, it transforms. It becomes the very fabric of its environment, a living, breathing piece of the seafloor that vanishes in plain sight. This is not just a trick of the light or a clever hiding spot, it is a biological marvel, a performance of such speed and precision that it borders on magic. The octopus challenges our understanding of what it means to be seen. Invisibility is not an illusion, a dynamic, controllable state, a superpower honed over millions of years. The octopus inhabits a world of staggering diversity and perpetual danger. Watch this. An octopus vanishing in an instant. From the sun-drenched shallows of vibrant coral reefs to the cold, dark depths of the abyssal plain, these creatures have colonized nearly every marine habitat on Earth. In a bustling coral reef, the scenery is a complex tapestry of shapes, colors, and textures. Here, an octopus must be able to mimic the intricate patterns of sponges, coral branch edges, and the shifting dappled light filtering down from the surface. Contrast this with the seemingly barren expanses of the sandy seafloor. To our eyes, it might appear monotonous, but for an octopus, it is a canvas of subtle variations, patches of fine sand, gravel, shell fragments, waving seagrass. Then there are the twilight zones of the deep ocean, where camouflage is not just about color, but manipulating light itself. Some octopuses absorb light to appear pitch black. Others use bioluminescence to break up their silhouette. The magic of the octopus's transformation lies within its remarkable skin, a living canvas controlled with astonishing precision. The primary tools for this artistry are specialized cells called chromatophores: black, brown, red, yellow. These sacs are surrounded by minuscule muscles directly connected to the octopus's brain. When the muscles contract, they pull the sac open, stretching pigment into a wide, flat disc that makes the color visible. This simple mechanism, repeated millions of times across the skin, allows for instantaneous and complex changes in color. What makes this system truly extraordinary is the speed and control with which it operates. Beneath the chromatophores lie two other types of cells that add depth and complexity to the disguise. Iridophores are like tiny, stacked mirrors. They reflect ambient light. Leucophores form a base layer that reflects broad-spectrum light, like a painter priming a canvas. The muscles controlling chromatophores are wired directly to the octopus's large, sophisticated brain. A change in appearance is not a slow hormonal reaction, but a neural one, as fast as a thought. By contracting specialized muscles in its skin, it can create bumps, spikes, ridges, transforming smooth body into a jagged surface. It can mimic a coral head, a mossy rock, a clump of seaweed, sculpting itself into the world. Witnessing an octopus deploy its camouflage is to see the impossible happen. Imagine a diver exploring a coral garden, admiring a particularly vibrant piece of brain coral. A section of the coral suddenly detaches itself, smooths its surface, and jets away, revealing itself to be a common octopus. Another stunning example can be seen in the sandy flats of Indonesia, home to the mimic octopus. When threatened, it may dive into a burrow, leaving two arms exposed, changing their color and waving them. It changes black, then yellow, waving them in opposite directions to imitate a sea snake. Consider the wonderpus. When hunting crabs, it may spread its webbed arms into a canopy, displaying white stripes and spots on a reddish-brown field. This diamatic display can startle or confuse prey, making them easier to catch. An octopus foraging might be startled by a sudden shadow passing overhead. In a fraction of a second, its body can flash to white or form a disruptive pattern that breaks up its outline. This rapid change can confuse a predator as it jets away, often releasing an ink cloud to add to the confusion. These real-time transformations remind us the octopus's skin is a dynamic tool, a language of survival spoken in color and light. The octopus's extraordinary ability to camouflage is the product of a relentless evolutionary arms race, millions of years of predator and prey struggle. Sharks, dolphins, seals, and large predatory fish. Every improvement in a predator's sensory systems drove the octopus to perfect its disguise. Camouflage became its primary line of defense. This passive defense conserves energy and allows the octopus to remain safe while expending minimal effort. The success of this strategy is evident in the octopus's proliferation across the world's oceans. But camouflage also serves an offensive purpose: ambush hunting. It flattens, resembles algae or rock, and waits for an unsuspecting crab. In a flash, it lunges. Arms envelop the victim before it can react. The same masterful system serves both needs. They did not evolve separate tricks for hiding and hunting. It is both a shield and a hunter's deadliest weapon. While blending is remarkable, some octopuses take deception further. They actively mimic other animals. The mimic octopus of Southeast Asia has a repertoire of characters it can play, altering shape and movement. It can pull its arms together, flatten its body, and undulate like a flatfish. It may become a lionfish, spreading arms like venomous spines and adopting a swagger, or mimic a sea snake with black and yellow arms, convincing predators to back off. Some species gather shells or stones to build fortresses around their den, a behavioral camouflage. The veined octopus can walk on two arms with others bundled overhead, to resemble a rolling coconut or clump of algae. Instead of fleeing, an octopus may match the current, hold rock-like texture and drift, becoming indistinguishable from debris. These behaviors demand immense control and environmental awareness. Advanced mimicry and behavioral deception show camouflage is not just reflex, it is thoughtful, dynamic performance. The octopus's camouflage is not merely reflex, it is orchestrated by one of the most intelligent minds among invertebrates. The octopus brain, with 500 million neurons, rivals that of some mammals. Octopuses are thought to be colorblind. Their eyes have only one photoreceptor. One theory: the skin contains opsins. The skin may sense ambient wavelengths and adjust chromatophores locally. The brain still masters overall pattern and texture, while the skin fine-tunes color, a distributed, efficient system. In labs, they associate patterns with backgrounds and improve disguises over time, showing learning and memory. They open jars, use coconut shells, and build shelters, evidence of problem-solving. The decision to blend, mimic, or display is calculated, not merely instinct. The brain manages millions of skin cells. The skin executes commands. This synergy enables tactical deception and tool use. It can weigh risks, anticipate others, and choose the perfect illusion. It is thinking its way to invisibility, one of the clearest examples of embodied cognition in nature. And that intelligence has not gone unnoticed by human engineers. The octopus's mastery of camouflage has not gone unnoticed by human engineers and scientists. Its ability to change color, its ability to change texture, and its ability to change shape represent dynamic material control. Researchers mimic chromatophore networks to create flexible sheets that change color and pattern on demand. Imagine military vehicles that adapt and clothing that changes to surroundings. An octopus can squeeze through tiny cracks and manipulate objects with dexterity. Engineers build soft robots from silicone and pneumatic systems to mimic this flexibility. These robots could navigate rubble or perform minimally invasive surgery with reduced tissue damage. Thin elastic materials with microchannels can inflate into bumps, mimicking octopus papillae to create reconfigurable textures. This could yield tactile displays, haptic VR interfaces, and aids for the visually impaired. A distributed sensory network, skin that senses and reacts locally, could make systems more efficient and resilient. Scientists are uncovering principles and applying them to human problems, turning the octopus into our teacher. The octopus stands as one of evolution's most brilliant and mysterious creations. It is a solitary, intelligent being armed with a mind and body that defy expectations. Its ability to vanish is a profound expression of a unique evolutionary journey. Fragile marine ecosystems the octopus calls home are under threat. Preserving its world is essential if we are to keep learning from its genius. The vanishing octopus leaves us with awe and chapters yet to be read. If you loved this deep dive into Mimicry Master, like, share, comment, and subscribe for more.